Hello, welcome back. Today we'll be looking at scientific notation. So, what is this scientific notation? It is referred to as expressing a number as a product of any number between 1 and 10 to the 10th power. It is mostly used when dealing with large numbers, as this one is able to shorten the notation. So I've a few examples, or I've put few examples that I'm going to use to explain how to change what I termed as original number to scientific notation. So let's first look at number 1. We are given 0,00125. So what needs to happen here is the shifting of this point. We are going to shift this point to the right. When we come across a number which is not 0, it can be 1, or 2, or 3, 4, 5, 6, 7, 8, 9. After passing that number, that's where we will rest this point. Let me use this laser pointer to demonstrate how we arrived at 1,25 multiplied by 10 to the power minus 3. As I've said, we are going to shift this point, and we're shifting it to the right. As we shift it, we'll pass the first 0, second one, then we pass a number which is 1, because earlier I said the numbers that we're interested in are 1 up to 9, not 0. So let's do it again. 1, 2, 3. This point is going to be positioned between 1 and 2. You can see it here, that is between 1 and 2. So I have 1,25. 1,25 multiply by 10. Multiply by 10. But something had happened here. This 10 is carrying something. Why is it carrying minus 3? It is carrying minus 3 because we are shifting this point to the right. As you shift it to the right, the exponent that will be on this 10 will be negative, and the number will be determined by how many times or how many numbers have you passed. In this case, we passed 1, 2, then 3. That's why we have minus 3 as our exponent. So the rule here is when you shift this point to the right, you subtract your exponent, or the number that you have shifted this exponent. If it's 3 times, that 3 must carry minus. So let's come to number 2. Number 2 is 2, and how many zeros? 9 of them. The comma here is not visible, but it is here. That's where the comma is positioned. Now we have to shift it until we reach 1 or 2 or 3, 4, 5, 6, 7, 8, 9. In this case, we are going to shift it to the left. Remember, in the previous one, we were shifting it to the right. and then the exponent carried a negative sign. Now in this one, because we are going to shift it to the left, the exponent will carry positive sign. Let's do it and see how many times we are going to shift this point here, which is not visible. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where I'm going to place the point. And I've moved it 9 times. So my answer here will be 2 multiplied by 10 to the power positive 9. So the rule here is when you move the comma to the left, it must carry a positive sign. And the number will be determined by how many times you have moved that point. In this case, we moved it 9 times. Let's look at number 3. 90. How do I write this in scientific notation? There is invisible comma here. I'm going to move it to the left. How many times? Yeah, it will be once. And it will be rested here. My answer in this case, it will be 9 multiplied by 10 to the power positive 1. Let us look at number 4. Where is this point that we focus on most of the time? Yes, visible. You can see that I've pointed at it. In this case, we are going to move it to the right. That's where we'll come across the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. In this case, the number that will come across first will be 6. Now, let's move this point. 1, let me do it again. 1, 2, 3, 4, 5. I have moved it 5 times. And I'm going to place it between 6 and 4, which is 6,43. Multiply by 10 to the power. Because I'm moving it to the right, the exponent will carry a negative sign, which is 10 to the power minus 5. Let's see what will happen in number 5. Where is this point? It is here. We're going to move it to the left. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I've put the comma between 1 and 2. Now I have 1, 2, 5. Multiply by 10 to the power 5 because I've moved it how many times? 5 times. 1, 2, 3, 4, 5. Moving it to the left. That's why it is carrying a positive sign. Let's look at number 6. We are given an ordinal number in this form. One can say it is already in scientific notation. What is it that we must do here? So we want to leave one number, for example, 1 or 2 or 3 or 4, 5, 6, 7, 8, 9 alone. You see, I can put the point here. I can even put it here or here. But in the examples that I'm doing here, most of the time, I want one number before this point. In this case, to take this further, what must I do here? Where is this point that must be moved? The point is located here. And then I'm going to move it to the left. It will be 1, 2. 1, 2 to the left. And remember, when you are moving this point to the left, the number that we get, in this case we're getting 2, it must carry a positive. In this case, we already have 10 to the power 2. What is it that we must do with the positive 2 that I got here? I must put it next to this 1 together with its sign, which is positive, which means that at the end, these 2 and the other 2 that I got by shifting the point here will end up adding here. 2 plus 2 will give us 4. Our final answer here is 2,81 multiplied by 10 exponent 4. So you can try other examples in order to practice what I was telling you. This is how numbers are changed to scientific notation.